Sometimes we want to know a little bit more than just how many people are in a population or how many objects or how many animals. Instead, we want to know some characteristic about those things and how prevalent maybe that characteristic is. So these things could look like how many of the light bulbs are defective, or it could also look like how many people intend to vote for the Republican candidate in the coming election. Whenever we're setting out to do this, it's difficult to poll or survey, ask the questions, of the entire population. So we end up taking what's called a sample. Now, samples can be very, very good, or they can be very, very bad. And it really depends on how you go about taking your sample and how large your sample is. So if I'm thinking about the population of the United States, and I only take a sample of, say, 20 people, that's a really bad sample because the United States have people who live in 50 different states. And among that, we have a variety of races, we have a variety of backgrounds, we have a variety of ideologies, all represented within that millions of people that live there. So one of the things that we want to consider when we're taking a sample is keeping the sample large enough that it can encompass all of the variability in our population. So that means that we can have different size populations that all have the same size sample that's effective for them. For example, my defective light bulb example. If I am looking at a population of 1 million light bulbs, or just a population of 1,000 light bulbs, the only characteristics of the light bulbs is they're either defective or not. They're very uniform otherwise. And so a sample can be maybe 100 light bulbs for each, my 1,000 and my 1 million population. That's not usually the case with people. With people, we usually need a large sample size because any one person is going to represent a variety of characteristics. So let's talk a little bit about the way that samples can go wrong. So when a sample goes wrong, it's considered a biased sample. And a sample is biased if any member of the population is more likely to be chosen than another member. It doesn't have to be an intentional thing. Just if that occurs, then the sample is biased. And consequently, it's not a good sample. We're first going to talk about selection bias. Now, selection bias is one that occurs when your target population and the frame that you're selecting your sample from don't necessarily overlap completely. So one easy way to think about this is geographically. Say my target population is everyone who lives in the state of Washington. And say I'm going to take a poll by sitting on the border of Washington and Idaho and asking all the people around. So I ask a sample of people around out on the border of Washington and Idaho, and I actually end up with some answers from people from Idaho that are completely irrelevant to the population I'm interested in, and I end up with some answers from people from Eastern Washington. The chances that Western Washington is represented at all in my sample are very slim. And it would just be if somebody happened to be traveling to Eastern Washington. So for those in Western Washington who pretty much never venture to Eastern Washington, then I wouldn't be representing them at all. That's an example of selection bias. Hopefully, selection bias is obviously not a good thing because it doesn't encompass my entire population and give everyone in my population an equal chance of being selected for the sample. Another type of sampling bias occurs through a method called convenience sampling. Convenience sampling is usually used either to save time or money on the part of the person taking the sample. For example, If you are interested in learning how much St. Martin's students enjoy their math classes, and you decided that you only needed a sample size of about 15 students, and you looked around you and you noticed that in this class there are about 15 students, so you decide to just survey them all because you have easy access to them via email or in person when we meet, then you will have gotten a sample, but your sample will only be people who have taken math in modern society. Your sample won't include people who have taken other math classes, or if they have taken other math classes, they haven't taken math classes for majors, they haven't taken classes that engineering majors take. There are a whole bunch of math classes that are not represented. And the likelihood that they've seen the variety of math professors here at St. Martin's is very slim. If you conducted a survey this way, what you will have done is a convenience sample for the sake of saving time in having to choose students randomly from the entire student population and manage to make the effort to reach out to them. Another type of bias that enters in is something called response bias. Now, response bias is one where the people who are more likely to respond are more likely to have strong opinions one way or another. In fact, they're most likely to have strong opinions negatively. You don't get the cross-section of opinions when you send out a blanket survey to everyone in America asking them to rate their experiences with the Postal Service. The people who have had good experiences, some of them might say something. The people who have had okay service, some of them might say something. The people who have had real problems, those are the people who are going to respond. So we also can have something called response bias. And a lot of times response bias is towards the negative end. The people who have things that they are unhappy about are more likely to respond than others. So we're always interested in our response rate as well when we ask survey questions of the population at large through something like a mail-out survey. Back in the 1930s, there was a new kind of sampling introduced called quota sampling. And the idea behind quota sampling was to guarantee that you actually get like the right cross-section of your population when you're taking your sample, which is really good intentions behind it. So let's think about why this might not work. So with quota sampling, I'm going to take enough people, I'm going to say, hey, you know what? I know that I need this many white people, this many black people, this many Hispanic people, this many women, this many men, this many people from Maine, this many people from Texas, and I'm going to go about it that way. And I'm not going to stop taking people into my sample until I've reached my quota in each one of those things. And once I get enough white people, I'm going to stop asking white people. And once I get enough black people, I'm going to stop asking black people. And so you're filling quotas in all of these ways. Now, quota sampling really famously predicted that Dewey was going to beat Truman in a presidential election, and it was an early example of a massive upset from what we were expecting. So why didn't it work? Well, first off, when you're taking quota samples, you are somewhat, as the pollster, choosing who to ask. And along with that, you're choosing them based on what you can see about them. So to any one person, there are so many dimensions of things that might drive who they are ideologically. For example, me. I'm white, I'm a woman, I'm from a very rural farming and fishing community in Maryland. I lived in Kentucky for 8 years. I went to a liberal arts school in Pennsylvania. I've lived in the Middle East. I've lived in England. I worked at the United States Military Academy for 3 years. So I lived in New York for 3 years. And now I live in Washington. And that's just the things about where I've lived and what I look like that drive my ideologically. That's not getting into any of my system of beliefs. Those are just some things that might have influenced them. A pollster coming up to me and asking me questions isn't necessarily going to know. They're just going to be taking me as the white woman who's giving them an opinion. They're not going to know that my opinions might be driven by things that are maybe not representative of white women, if even such a thing exists. So now that we've talked about a whole lot of ways that we can do sampling badly and come up with not good samples, let's talk about how we can come up with some good samples. So random samples. Random samples are what we want. If we can take the person out of the choosing the sample, it's ideal. So one of the things that we use computers for is to select the people that we're going to poll. And we let the computer choose phone numbers that are going to get called. We let the computer choose addresses, and we randomly choose them, and then we call them, or we write to them, or whatever the case may be. Random sampling can occur in multiple ways for different purposes. So the most simple one is called simple random sampling. And with simple random sampling, what you're doing is you're really taking your population at large and you're choosing the size sample that you want from it. So if I have a population of 1 million people, I can assign them all a number, and I want a sample of 200. I pull 200 numbers, and those are the 200 people. That's a simple random sample. Now, sometimes I want to guarantee that I actually ask some people from every state who they're thinking about voting for in the next election. So the whole idea behind that quota sampling thing was not necessarily a bad idea. It was just executed in a poor way. So we have a random sample alternative to it now, and it's called stratified random sampling. So what you do with stratified random sampling is you break your population into different strata, all right, or separate groups based on some characteristic. So I might say, here are white Americans, here are Black Americans, here are Hispanic Americans, and so on. And I'll have this array of strata based on race, and then I might say that I want to know somebody from every state within each of these strata. So you can actually break strata into substrata as well. So I can take my group of white people and I can break them into people from each of the 50 states. So now for every race that I have, so white, Black, Hispanic, Native American, Asian American, etc., I have these 50 substrata. And you can bake your substrata into sub-substrata and so on. And then what you do from each of those is you take a random sample from each of whatever your smallest level is, and that guarantees that each one of those smallest level groups that you've made is represented in your sample. There are more sampling techniques. There are more things about sampling. Really, this entire section is a course or 5 in and of itself, but we're just going to brush the surface with what we've just talked about, and that's what we're going to focus on for the purposes of this course.